Think about your daily life for a second. Every time you scroll through social media or buy something online, maybe even just save a note on your phone, you're interacting with this like huge invisible ocean of data, personal lists, company reports, data is just everywhere. But how do we actually make sense of it all? How do we organize it? Get what we need quickly, make it useful. Well, today we're taking a deep dive into SQL. That's SQL, Structured Query Language. It's kind of the silent workhorse behind, well, so much of the digital world we use every single day, often without even realizing it. And our sources today, they give us this incredible roadmap, really pulling back the curtain on this foundational tech, revealing its power, from simple tasks right up to the cutting edge, like AI.
Absolutely. And our mission here, for you, the listener, is really to pull out the most important nuggets from these sources. We want you to walk away with a clear understanding of what SQL actually is, why it's so incredibly versatile, across so many different fields, and how it impacts pretty much everything. Managing your favorite apps' data, powering the future of AI. By the end of this, you'll have a really solid grasp of this critical language.
Okay, so let's unpack that first bit.
Yeah.
What is SQL exactly? It sounds technical, but maybe the idea behind it is simpler.
It is at its heart. Basically, SQL is the standard language for talking to relational databases. Think of it like a universal translator, but for structured data. Its main job, data management. It lets you literally have a conversation with the database. Need to create something new, delete something old, update info, or just, read what's there. SQL gives you the precise commands for all that, and what makes it so powerful is how widely it's adopted. You'll find SQL working across all sorts of systems: MySQL, Oracle, PostgreSQL, SQL Server.
The big names.
Exactly. And its core function is with those relational databases, the ones designed to organize data really neatly into tables, kind of like superpowered spreadsheets, but much more robust and interconnected.
Right. And to really get a feel for it, seeing it in action, even just conceptually, helps a lot. Our sources do a great job walking through a classic Hello World example. It shows those basic powers, right? Defining structure, putting data in, getting it back out.
That's right. So imagine you're starting totally fresh. First, you'd need a database server running like MySQL maybe, and you'd need access to its command line. That's where you type your instructions.
Okay, so I'm sitting at my computer, ready to type. First step, create the database itself, like a container.
Precisely. You'd tell the system, create database testDB, simple as that. Now you have a space.
Got it. Then I need to tell it I want to work inside that space.
Yep. You type USE testDB, now you're focused on that database.
Okay. Next, the structure for my message. That's the table, like setting up columns.
Exactly. You need to define where the data will go. So you type create table greetings, int auto increment primary key, message varchar 255. Let's break that down slightly. Int auto increment primary key sets up an automatic unique number for each message. And message varchar 255 creates a text field holding up to 255 characters, perfect for short messages.
Okay, defining the data type. Varchar for text. Makes sense. And now, the actual message.
Now the fun part. To put hello world into that message column, you use insert into greetings, message, values. Hello world, you've just stored it.
And finally, to see it, to prove it's there.
You ask for it back, you type select message from greetings, and boom, hello world should appear on your screen.
That's actually pretty cool. Simple, but you see the whole cycle. And our sources even suggest trying it with your own name instead of hello world in that insert command. Imagine typing that and seeing your name pop up. It suddenly makes this abstract data thing feel really tangible, doesn't it?
It really does. It clicks.
So that hello world, simple as it is, really opens the door. But why is SQL so essential today? It feels like maybe it's just for database people.
But that's the misconception. Its reach is, well, enormous now. SQL's critical role today comes from how seamlessly it plugs into such a diverse range of technologies. We're way beyond just traditional relational databases. Its influence stretches into, machine learning, AI, even things like blockchain. The key is that SQL works so well with all these different database management systems. It helps you interact with data, whether it's in a superstructured relational database or something else entirely. Really efficient data management, which SQL is all about, is the backbone of almost everything digital now.
Okay, so let's break that down. Where specifically does it make a difference?
Right. Let's look at some areas. First, data science and analytics. SQL is absolutely fundamental here. Querying huge data sets, cleaning up messy data, doing deep analysis. Data analysts rely on it constantly. They use it to generate the reports and insights that businesses use to make decisions. It's foundational for strategy.
So understanding the past, predicting the future, basically.
Exactly. Then, machine learning and AI. SQL is crucial for prepping the enormous amounts of data needed to train models. Cleaning, transforming, extracting the right bits, you need high-quality data for AI to work. And SQL helps manage that whole process. It basically feeds the AI brain.
Okay, that makes sense. What about web development?
Oh, it's everywhere in web development. Managing user accounts, handling e-commerce transactions, storing website content, especially in applications built with frameworks like Django or Node.js or Ruby on Rails. Those dynamic websites we use all the time. Your profile, your shopping cart, your comments. SQL is making that possible behind the scenes.
Right, wouldn't work without it.
Pretty much. Then think about cloud and big data. SQL is deeply integrated. Cloud databases like Amazon RDS or Microsoft Azure SQL, they speak SQL. Big data platforms like Apache Hive, they use SQL or SQL-like languages to let you query massive distributed data sets. It's like the universal remote for all this data, big and small, cloud or local.
Even blockchain. That seems surprising.
Yeah, even in blockchain and decentralized systems, it's often used for managing the off-chain data. So data that doesn't need to be on the blockchain itself, but needs to be stored and retrieved efficiently to support the system. It complements the ledger tech.
Wow. Okay, so the takeaway here is clear. SQL isn't just for database admins. It's foundational. It's a core skill across, well, almost the entire tech landscape. It really is everywhere.
Absolutely. It underpins so much.
So to really wield this power, we need to understand its vocabulary,
Yeah.
right? The basic commands, the concepts. Our sources break these down into like building blocks, which is helpful.
Yeah, that's a great way to think about it. These components are often grouped by what they do. First, you have the absolute SQL basics. This is stuff like data types, knowing if you're storing text, numbers, dates, because that affects everything. And operators, for comparisons like greater than or equal to, and the fundamental commands.
Okay, and these commands fall into categories.
They do. When you're defining the structure, like creating a database or changing a table, you're using data definition language, or DDL. Think create database, drop database to remove one, or create table to set up your columns, alter table to modify it later, drop table to delete it. That's all DDL defining the containers.
All right, shaping the database.
Exactly. But when you're actually working with the data inside those structures, adding, changing, deleting, retrieving records, that's data manipulation language, or DML.
DML, got it.
So select is your main tool for retrieving data. Insert into adds new rows, update changes existing ones, and delete removes rows. That's DML in action.
Okay, DDL for structure, DML for the data itself. What else?
To make your DML, especially select, more powerful, you use SQL clauses. These let you filter, organize, group results. Where is huge. It lets you specify conditions, like where country is Canada.
Filtering. Very useful.
Extremely. Order by lets you sort your results, say, alphabetically or by date. And group by Y is for aggregating data, maybe finding totals per category.
Okay, clauses refine the queries. What about operators? You mentioned those earlier.
Right. SQL operators are the symbols and keywords for building more complex conditions in your where clause, usually. Things like AND or to combine conditions, like for pattern matching, like finding all emails ending in d.com, or SNLL to check if a field is empty.
Got it. And you mentioned aggregating data with GRUUPY. Are there specific functions for that?
Yes. SQL aggregate functions. These make calculations super easy. You can count the number of rows, sum up values in a column, find the minimum or maximum value, or calculate the AVG average.
Wow, okay, so instead of pulling all the data and calculating it elsewhere, you just ask SQL to do it.
Precisely. These functions are critical for business intelligence. Finding your top product, average order value, new user count, that's all aggregate functions. They turn raw data into insights.
That's powerful. What about keeping the data accurate? Any tools for that?
Definitely. That's where data constraints come in. These are rules to maintain data quality and integrity. Not null means a field cannot be empty. A primary key constraint assigns a unique ID to each row, super important for identifying specific records. Think of it like a serial number.
Okay, unique ID.
Then a foreign key links a field in one table to the primary key in another table. This is how you connect related data, like linking a customer record to their order history. Keeps everything consistent.
The relationship part of relational database.
Exactly. Unique ensures all values in a column are distinct, like for email addresses, perhaps. And finally, SQL joins. These are maybe one of the most powerful concepts. They're how you combine data from multiple tables based on those related foreign key connections.
Merging tables together.
Right. Join, left join, right join, full join. They all do it slightly differently. A standard join brings back rows where there's a match in both tables. A left join gives you all rows from the left table and any matching rows from the right. Super useful if you want, say, all customers, even those who haven't ordered anything yet.
Okay, that sounds incredibly useful for real-world questions.
It is, and what's really amazing is how all these pieces, commands, clauses, functions, joins, work together. You can build incredibly complex queries to answer really specific questions.
That's quite a toolkit already. But SQL doesn't stop there, right? There are more advanced
Oh
tools.
yeah, it goes deeper. Beyond the core stuff, you have things like built-in functions. These aren't just the aggregate ones. There are functions to manipulate dates, work with text strings, perform numeric calculations, all directly within your SQL query. Saves a lot of hassle.
Okay, more built-in helpers.
Then there are SQL views. Think of a view as a saved query, a virtual table. Let's say you have a complex query you run often, or you want to give certain users access to only part of a table for security.
Like hiding sensitive columns.
Exactly. You create a view based on a query. It simplifies things and acts as a security layer. People query the view, not the underlying tables directly.
Smart. What else speeds things up?
SQL indexes. These are crucial for performance. An index helps the database find specific rows much faster, especially in large tables. It's like the index in the back of a book. Instead of scanning every page, you look up the topic and go straight there.
Makes sense. Less searching.
Right. And for really complex data retrieval needs, you have SQL subqueries. This is basically putting a query inside another query. It lets you break down complex problems into smaller, nested steps.
Query inception.
Kinda. And the sources also mention other advanced topics. Window functions for complex calculations across sets of rows, stored procedures to save blocks of SQL code on the server, transactions for ensuring multiple steps happen safely together. Lots of depth there for tuning and managing complex stuff.
It's clear SQL is deep and always evolving.
Mhm.
And speaking of evolving, there's a really interesting trend mentioned for 2025, something about AI.
Yes, this is fascinating. SQL Server 2025 is apparently introducing AI features directly into the SQL engine. We're talking native support for vector data types, which are key for AI similarity searches, and even managing AI models right there in the database.
Whoa, so you could run AI tasks using SQL.
That seems to be the direction. Running AI tasks directly in the database rather than pulling data out to a separate AI tool and putting results back. The implication is pretty big. Data professionals won't just be managing data for AI systems. They'll increasingly need to structure and manage data as if it's already part of an AI workflow. SQL becomes the language for orchestrating intelligent data.
That really blurs the lines between database management and AI development.
It does. It raises big questions about how skills and roles will shift for data pros moving forward. Very exciting, though.
Definitely something to watch. So all this power, this evolving landscape, what does it mean for careers? If someone learns SQL, where can that take them?
It's a massive advantage. SQL is a fundamental skill for so many tech roles. Now, it's usually not enough on its own for the top jobs. You often need knowledge of specific databases, cloud platforms, maybe programming languages too. But SQL is very often the essential starting point, the key that unlocks the door.
So what kind of roles are we talking about?
Well, you've got SQL developers who focus specifically on designing, building, managing databases. Salaries there can range roughly $84,000 up to maybe $153,000 USD bar. Then data analysts. They use SQL heavily for querying, reporting, finding insights. Average salary around $85,500 USD.
Okay.
Data scientists use SQL constantly too, especially for pulling and preparing the vast data sets they need for building predictive models. Salaries there might be $70,000 to $130,000 USD, maybe higher. And big data engineers who build and manage large-scale data pipelines, often using SQL or similar languages in platforms like Hadoop or Spark. Those roles can command salaries from, say, $125,000 up to $300,000 USD or more, depending on experience and location.
Wow. Quite a range, but clearly a valuable skill.
Definitely. And it's not just about individual roles. SQL is also key in how software systems are built. Think about common architectures. In a client-server model, SQL is often the language the client application uses to talk to the back-end database server. In a three-tier architecture presentation, logic, data SQL is the interface to that crucial data tier. It manages the flow of information throughout these systems, making sure everything connects and works smoothly.
So it's not just a language. It really is like the plumbing or the wiring for information in almost any data-driven setup.
That's a good analogy. It's the standard way things connect and communicate when it comes to structured data.
It's clear understanding SQL gives you a powerful lens for seeing how the digital world is put together. What a journey. We've gone from the absolute basics to finding SQL, running that hello world, all the way through its huge impact in web dev, AI, even blockchain, plus those really interesting career paths that are opening up and evolving. It's been a fantastic deep dive.
It really has, and hopefully you, the listener, have seen how SQL acts as that vital go-between. It lets us manage data, analyze it, and ultimately unlock the insights hidden within the information that powers, well, pretty much everything today. From just storing a name to training complex AI, it truly is the language of information.
So here's something to think about as we wrap up. Consider an app or a website you use every single day. Maybe it's social media, an online shop, even just a simple notes app.
Huh.
How do you imagine SQL might be working? Silently, behind the scenes, storing your profile, your preferences, that post you just made. What new questions does this deep dive spark for you about the data you interact with constantly and this invisible, powerful language that makes it all work?